Hello guys, what's up? This is Sir EJ and welcome again for another math tutorial. In today's topic, we will be discussing all about word problems involving right triangles. These are the following objectives we need to attain for today's topic. Letter A. Use trigonometric ratios to solve real-life problems involving right triangles. Letter B. Identify the 6 trigonometric ratios. And letter C. Solve problems with perseverance and accuracy. The applications of right triangle in real life are vast. Hence, it is important that you will be able to accurately solve the word problems under this lesson. The following steps are suggested whenever you are solving word problems involving right triangles. So the first one is we need to read the problem carefully. After that, draw a picture based on the information provided by the problem. Then, the third step is to label the parts of the triangle form. And then for the fourth step, set up trigonometric ratios to be used in solving the unknown. And for the last step, we will now solve and answer the question. Let's have our first example. The dimensions of a rectangle are 50 centimeters and 94 centimeters. We will find the measure of the angle made by the diagonal and the shorter side. So our first step here is we need to draw the picture. So this will be our illustration. We have a given rectangle wherein the measure of the width is equal to 50 centimeter and the measure of the length of the rectangle is equal to 94 centimeter. And then we are looking for the measure of the angle made by the diagonal and the shorter side of the rectangle. So we are looking for this angle. So we will let theta the angle made by the diagonal and the shorter side. So this will be theta. And then after that, we will set up the trigonometric ratio. So what trigonometric ratio we will use to solve this problem? So if this one is our reference angle or our given angle, then this one will be the opposite. We have a given value for the opposite side. And also we have the given value for the adjacent side. So obviously we will be using the formula of the tangent ratio. So we have tangent theta is equal to opposite over adjacent. All we need to do is to substitute the corresponding value. Opposite will be 94 centimeter and the adjacent side is equal to 50 centimeter. And then after that, we will divide these two numbers. 94 divided by 50 is equal to 1.88. And then we will divide this both sides by tangent. So tangent will be cancelled out. So this will be theta is equal to tan raised to negative 1 or arctan times 1.88. And then you will press this on your calculator. Just press shift tan, then 1.88. So theta will be equal to 61.99 degrees. Therefore, the measure of the angle made by the diagonal and the shorter side of a rectangle is equal to 61.99 degrees. Let's have our second example. One of the equal sides of an isosceles right triangle is 20.1 centimeters, and the vertex angle is equal to 68 degrees. We will find the length of the base of the triangle. Our first step again is we need to draw the picture. So I have already here the illustration wherein this is the isosceles triangle. When we say isosceles triangle, two sides are congruent with each other. We will label this isosceles right triangle, and we all know that the vertex angle is said to be equal to 68 degrees. So this angle is the vertex angle, which is equal to 68 degrees. And then the sides of the isosceles triangle is equal to 20.1 centimeters. So this side and this side is both equal to 20.1 centimeter. And we are looking for the base of the triangle, this one. So for us to apply the trigonometric ratios, we need to construct a right triangle. So we can construct a right triangle by drawing an altitude here. So if we will construct an altitude here, we will be having here a right angle. And if we have a right angle, then this will be a right triangle. So we will be using this right triangle. So we all know that this is equal to 68 degrees, and then the altitude bisects the vertex angle. So the angle which is equal to 68 degrees will be now equal to 34 degrees. It will be divided by 2 to get this angle. So we have 34 degrees. This one will be equal to 20.1 centimeter, and let's label this as y. Now for our solution, let x is equal to the length of the base of the triangle and y is equal to the length of the half of the base of the triangle. And after that, we will be using trigonometric ratios. So what trigonometric ratios we will be using in this given figure? So this one will be our reference angle. So we have to compute for the measure of y. So this one will be the opposite side. And given is the hypotenuse. So which of the trigonometric ratio has the opposite side and the hypotenuse? So that is sine theta. So sine theta is equal to opposite over hypotenuse. All we need to do is to substitute the corresponding value. So we have sine 34 degrees. The value of theta is equal to 34 degrees equals the opposite side of our reference angle again is equal to y all over the hypotenuse, which is equal to 20.1. And then after that, we will cross multiply sine 34 degrees times 20.1 is 20.1 sine 34 degrees equals y times 1 is equal to y. And then we will press sine 34 degrees on our calculator. We will get 0.55919, and then we will multiply it by 20.1. Multiplying these two numbers, y will be equal to 11.24 centimeter. So the measure of y is equal to 11.24 centimeter. Now to get the base or the length of the base of the triangle, we will just multiply it by 2. So 11.24 times 2 will be equal to 22.48. So therefore, the length of the base of the triangle is equal to 22.48 centimeters. Let's have our next example. Rin stands at the window of his condo unit so that his eyes are 53 meters above the level ground. From his location, the angle of elevation to the top of a skyscraper is 42 degrees. If Rin's condo is 116 meters away from the skyscraper, how high is the skyscraper? So we will be illustrating this by constructing its figure. So this will be our illustration. So this is Rin, and he is 53 meters above the level of ground. And then the angle of elevation that is formed is 42 degrees to the top of the skyscraper. So this one will be equal to 42 degrees, and Rin is 116 meters away from the skyscraper. So we are looking for the height of the skyscraper. So let x is equal to the height of the skyscraper, and then after that, we will be identifying what trigonometric ratios we will be using. So if this one is our reference angle, which is equal to 42 degrees, and we are looking for the height of this skyscraper, obviously we need this side, the opposite side of 42 degrees. And then same goes here, we have a given of 116, and this one will be the adjacent side. So if we need the opposite side, and if we have a given adjacent side, so obviously we will be using tangent. So the formula will be tangent theta is equal to opposite over adjacent. And we will substitute the corresponding value. So we have tangent 42 degrees is equal to the value of the opposite side, this one. So the value of the opposite side is x minus 53. Since the measure of this side, 53 meters, will be also equal to 53 meters, and if this is x, to get the measure of the length of this side, we will subtract it by 53. So x minus 53 to get the length of this side. So the opposite side will be equal to x minus 53. All over the adjacent side, the one in between our reference angle and right angle, which is equal to 116. And we will cross multiply this. So we have tan 42 degrees times 116 is equal to 116 tan 42 degrees. And then x minus 53 times 1 is equal to x minus 53. And then after that, we will just bring down x, and then equals, bring down 116 tan 42 degrees, then negative 53 transpose to the other side of the equation, it will become positive 53. And then after that, x will be equal to, bring down 116, press tan 42 degrees on your calculator, this will be equal to 0.9004 plus 53. And then bring down x again, equals 116 times 0.9004 will be equal to 104.45 plus 53 will be equal to 157.45 meters. So the measure or the height of the skyscraper is equal to 157.45 meters high.